Hello, in this video, I will discuss electric field of a disk from its center, a distance x from its center at point P. The radius of disk is r and the surface charge density is sigma. Surface charge density sigma means charge on per unit area, and you have to calculate the electric field at a distance x from its center. Let assume the center be O, and I will give you a key concept for calculating the electric field of this disk at a distance x from its center. You can assume that this disk is made up of rings, which are present from radius r equal to 0 to radius r equal to r. This is r equal to 0 and this is r equal to capital R. Okay. So electric field at a distance x from its center is electric field of all such rings which are spread over radius r equal to 0 to radius r equal to r. This would be the electric field of disk. This would be the electric field of disk. And as you know that the electric field of a ring at a distance x from its center having radius r is k times charge on ring times distance over r square plus x square whole raised to the power 3 by 2. This is electric field of a ring from its center at a distance x, and it is away from point P. This is point P. So you have to just calculate electric field of all such rings which are spread over radius r equal to 0 to r equal to r, and you will end up with electric field of disk. So this is our key concept. You have to keep this in mind. If you keep this in mind, you can easily bring out whole integration and you will get your answer. Now, assume a ring of width dr. The radius of ring is small r and that of disk is capital R. That of disk is capital R, and the radius of ring is small r. And you have to find the electric field due to this ring at a distance x. At a distance x. Let me change the color of pen. This is small r and this is capital R. Now, electric field due to this ring is k times q over ring times x over r square plus x square whole raised to the power 3 by 2 in outward direction. This is electric field due to this ring. When you integrate all such rings, the electric field of all such rings, you will get your answer. That is electric field of disk. Now you have to calculate Q of ring. What is charge on ring? As you know, charge is sigma times area of ring. When charge is distributed over area, when charge is distributed over length, then charge come out to be lambda times length. When in the case of a volumetric distribution, the charge come out to be rho times volume. So here the charge is distributed over area. So expression of charge on ring would be sigma times area of ring. And let me show more. So we show you more that this ring is just a strip. When you cut this ring from a scissor, you will get a strip having length 2 pi r, having length 2 pi r, and width dr. So the area of this ring is 2 pi r dr. This is area of ring. And when you multiply this area with sigma, sigma means surface charge density, then you will get charge of ring. This simple unitary method. Let me explain you more that what is sigma. Sigma is charge on unit area. Sigma is charge on unit area. Charge on unit area. Then charge on 2 pi RdR would come out to be 2 pi RdR times sigma. Simple unitary method. So this would be charge on ring. Now you can put this value in this expression over here. We'll get electric field of disk, good integration of all the rings from 0 to R, K times Q, sigma times 2 pi R dr. This is Q of ring times X over X square plus R square whole raised to the power 3 by 2. And you have to carry out this integration. K, sigma, 2 pi, X, they all are fixed. They are constant. You can carry out from integration and can put out from integration. And you will left with K sigma 2 pi X 0 to R dr over X square plus R square whole raised to the power 3 by 2. Now you have to integrate this expression. You have to integrate R dr over X square plus R square whole raised to the power 3 by 2 from 0 to R. Okay. And what was left outside the integration was K times sigma times 2 pi times X. Let me check. Yes, K times sigma times 2 pi times X. K times pi times 2 pi times K times sigma times 2 pi times X. Okay. Now, the integration of this expression can be solved through substitution. You can put X square plus R square as T. And when you differentiate this expression, you will get, look, this is constant X, which is fixed. So the differentiation of this expression with respect to T is 0, and that of R is 2R times dr over dt, and dt over dt is 1. So the value of R dr come out to be dt by 2. This is the value of R dr, because this is our numerator and this will be our denominator. And when we do substitution, and then we have to change our limits. Okay, this is lower limit of R and this is upper limit of R. Put this upper limit and lower limit in this expression, you will get two limits of T. When you put R equals to 0 and when you put R equals to capital R, you will get lower limit as X square and upper limit as X square plus R square. So the whole integration now converted into X square 2X square plus R square, and inside bracket we had RdR, so it get converted into dt over 2, and in denominator we left with t raised to the power 3 by 2, and we had k sigma 2 pi x outside the integration. You can carry out this 1 by 2 outside the expression too, and this will simply convert it into more simple expression. This is x square and this is x square plus r square t raised to the power 3 by 2 dt. And this is very simple algebraic integration. Everyone knows how to integrate such simple expression. Let me show you how to integrate. This expression can be integrated as t raised to the power minus 3 by 2 dt x square plus r square. The integration of this expression, I am just integrating this expression, will be minus power increased by 1. When you increase 1 minus 3 by 2 plus 1, you will get minus 1 by 2, minus 1 by 2. And that minus 1 by 2 will also divide into denominator. And you get t to the power minus 1 by 2. T raised to the power minus 1 by 2. This is our result after integration. Upper limit is x square plus r square and lower limit is x square. And the expression outside the integration was k times sigma times 2 pi times x over 2 cancel 2 from 2. And now you can also put this outside the box because this is also constant. When you put 1 by 2 outside the expression, and this 2 will multiply with k sigma pi x, and the expression will be like minus 2 times because we which was minus 1 by 2, and when you bring outside the box you will get minus 2 k times sigma times pi times x, and you will left with 1 upon root t. You will left with 1 upon root t because this is t raised to the power minus 1 by 2, which is converted into 1 upon root t. Okay, and the limits were x square plus r square. Now you can put limit. The expression will convert into root of x square plus r square minus 1 upon root of x square minus 2k sigma pi x. Cancel out root with square. You will left with minus 2k sigma pi x 1 upon under root of x square plus r square minus 1 upon x. You can send this negative sign inside the box and you will have 2 times k times sigma times x times 1 upon x minus 1 upon under root of r square plus x square. Okay. So this is our required answer. And when you put some other assumption like r is very big than x, then this whole expression, the denominator of this whole expression will convert into 0 because denominator will come out to be a very big value, and when upon some big value come out to be a 0. So we're left with 2 times k times pi was also there, 2 times k times pi times sigma times x times over 1 upon x to x cancel. You will left with 2k pi sigma. Now you can also put the value of k, 2 times pi times sigma times 4 pi epsilon naught, cancel out 2 times 2 and pi times pi. You will left with sigma upon 2 epsilon naught. This is our required answer after putting assumption. So I hope you understood this topic.